Hello. Hello.
Good morning to all of you and a very warm welcome to this National Science Day celebration. Today is we are just 2 days away from National Science Day, but we celebrate it as a National Science Week and we organize many programs. But I'm so happy to see so many young children, almost so far as residents are concerned, I think it's almost 2 years now. This place was always full of them because we get almost 7.5 lakh visitors. Out of them, 50% are exclusively students in organized groups, particularly school children. And once this pandemic started, then lockdown and lockdown and lockdown. So finally, we could see today, after that, it's almost 2 years.
Right.
We are able to see young children back to Science Center, and now I think we will also gain a lot of energy because children are always full of energy, and we are there. In fact, without them, we are nothing. So far as Science Center is concerned, our programs are concerned, our activities are concerned, we do it for you. Something very unique to Science Center is the experiments. So that is our USP. In the Science Center, if you go, mostly they are different than science museums, or museums rather. Museums generally we have a touch me not approach. The people are discouraged that you just watch, enjoy watching, don't touch anything. But here we encourage, do something, interact with the exhibits. Sometimes people tod bhi karte hain, problem nahi. Because Arvind Gupta sir has told the best thing a child can do with a toy, because these are toys, we call it as exhibits, we try to make it them sturdy, but they may be toys for them. When you are interacting with them, when you are playing with them, sometimes you can break them also. So now, considering the same thing, we have live science demonstration also. We do it regularly at Science Center, but we have some amazing experiments which people have developed out of their passion, out of their interest, apart from their regular activities as a teacher. So we have with us Shri Bhagwanji Chakradev, B.D. Chakradev, Bhagwan D. Chakradev. Bhagwan, sorry. He has demonstrated many times, and the impact of demonstration is such. I was discussing with him in the morning. Perhaps we have connected somewhere around 2002, 2003. And around that time, I saw some of his demonstration. Though he has been regularly doing that for us at colleges and schools. What I have learned, he has already done 2,600 shows of such kind in different throughout India. So, impact is such that you will not forget it. And that's what I am so happy that children are there. And I request if they can note down also. Teachers are also there. I will introduce him briefly. He's basically Masters in Physics and also in MPhil. Then from TFR and Mumbai University, retired as Associate Professor and as Head of the Department in Srimati CHM College, Ulhasnagar. He's elected member of Senate and Management Council of University of Mumbai. He has been awarded the Best Teacher Award from University of Mumbai. Was the President of Marathi Vigyan Parishad of Ambernath Vibhag. As I told you, he has already conducted 2,600 of such fascinating experiments, innovative experiments in science at various places all over India. He is doing R&D also in demonstration of experiments at his own lab and workshop which he has set up in his own residence. So that itself shows the passion and involvement he is having in the amazing experiment. I think many of them you are going to watch, so I will not take much time. With request, with all of you, with a big round of applause, joining me in welcoming Bhagwan Chakradev. Please, I request sir to take over and amaze the interest. Yeah,
yes.
And you will all enjoy it. I'm sure it will be going. You are going to remember it forever as I am doing. Sir.
Mic on? Can you hear me? Last, cheers. Okay, start. You know this machine. This machine is called an air blower. Very powerful motor, very high duty, heavy duty. And the moment I switch on, you get some typical sound, which you sometimes hear in your kitchen. Like this. This will blow the air at high speed. And when I put my hand, you can feel the pressure. But a science student should note this point that the air current which comes out is in diverging beam. You know, diverging beam, which is spreading out. Maxima of velocity is here, and if you go on the side, it goes on decreasing. That is very simple, common sense. If you plot the graph of velocity against some x-axis dimension, distance, the graph will become like this. You know what is this graph? Maxima in center, tapering down on both sides. Okay? But there is two-dimensional graph. Can you imagine 3D graph? Yes, 3D graph means it will be bell shape. You know bell shape? Very simple. Imagine. But this airflow is of no use for my experiment because I require directional airflow, one direction. So I do one attachment, that is called a nozzle, like hose pipe. Now, on this flow, if I make this on and test with my fingers, I can imagine a graph. See, the graph will be now like this. You know, the graph will be like this. What is the difference? Previously it was like this, and now it is so common sense. Very high peak, very narrow spread. Good. That is what I want. And on this airflow, if I keep this ball and leave it, what will happen? The ball will go high. Up to what height? 1 meter, 2 meter, 3 meter ceiling? No, it will not go to ceiling because that much air pressure is not there. And after going high, will it remain there or will it fall down? You can speak out. It will remain or fall? Fall. It will fall. Why will it fall? Gravity. Yes. But I am doing magic. So I defy gravity. Is it not magic? The ball is not falling. It is remaining stationary at one place, equilibrium. Now the question arises how this equilibrium comes, why it comes. And this was a problem solved by Daniel Bernoulli long back, 200 years back. This is a very peculiar science concept which I want you people to understand within 2 minutes. Very simple. If the ball is here, it is pushed up. If the ball goes up, gravity will pull it down. But if point will come there, the two forces will be equal and opposite. And the net force will be 0. What will happen then? The ball will attain equilibrium, stationary. You got it? But students ask me the question, why the ball did not fly away this way or that way or any direction? Why it is captured in this flow? The answer is very simple. That is Bernoulli's idea. What Bernoulli explained, if the ball is here, it is supported by air pressure. Okay. But if the ball tries to run away this direction, in that case, the velocity of air is large here and here it is small. So where there is high speed, the pressure of air on this surface will be less. Now what will happen? The surrounding air will push the ball in this direction because this way pressure is more. Now if the ball will try to go this way, what will happen? The surrounding air will push it here because here it is high speed. High speed means less pressure. So it is very simple, common sense. And you can remember only one sentence. What is the sentence? The surrounding air will keep on pushing the ball towards the central maxima line. Now people ask, what do you mean by central maxima line? Central maxima line is imaginary line acting on this pipe. Because I told you, velocity maxima is in center. Air blower principle. But so we have a very interesting point, and if the ball is flowing here, you can see that the ball can remain. This ball is going to less height. Imagine why. Logic. And this ball is going to more height. Now, one may ask the question, can you put the two balls together? Answer is yes, I can. Okay. Are you getting my point? But if I put this ball first and then this ball, it will not work. You can argue logically. Why? Why not remain like this? Okay. Let us go ahead. Now, if I have the ball stationary here and I play a mischief, what I do? When the ball is stationary, I bend this pipe. I change the direction of the air flow. Tell me what will happen. The ball will remain here or fall down or will go in this direction? It will go in this direction. Okay, let us see. What a great surprise. I have brought the ball here and I have pulled it back to central position without thread, without touching it. So remember why this happens? The reason is the ball will remain trapped in the air flow. Remaining trapped in air flow is because of Bernoulli principle. Okay, fine. Now, interesting question. When it is here and it is here, actually gravity is downward and air force is here, air pressure is here. So how it attains equilibrium? Think about it, you will get the answer. Think about it, you will get. I am not getting asking you questions here because very less time is there. I have to show several experiments, so no interaction now. Okay, but one question is very important. Suppose the ball is floating here, and when it is stationary here, I play again mischief. I switch off the motor. What will happen? The ball will fall down. But ball can fall in three different ways. Number one, the ball will fall in this direction, like projectile. Number two, the ball will fall vertically downward. Number three, the ball will fall towards the pipe. Which is correct? Opinion poll. Option number one, the ball will go in this direction. How many agree? Raise your hands. 1, 2, 3. Okay, some very few people. You say ball will go like this. Okay, second option, we'll have vertical ball. How many agree? Oh, very good. Some big number. Ball will have vertical ball. Okay. Third option, the ball will fall towards the pipe. How many agree? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First, very less number. So big number was for vertical fall, and that is wrong. I prove it. No vertical fall. It came down towards the pipe. Now try to argue logically why it came down towards the pipe. The answer is tricky. The moment I switch off, the motor doesn't stop immediately. It will have gradual decrease of speed. So the gradual pressure relief will keep the ball trapped in the air flow, and that is why it will come down as if it is sliding over an inclined plane. So people can't imagine this, how in air I can have inclined plane for a ball to slide down. But this is Bernoulli's miracle. Fine. So there are plenty of things I can show you, but I want to make a shortcut here. Now here, this ball is not going to large height. Simulation. And if the ball is here, I put my hand and I bring my hand down, my hand can never touch the ball. Oh, surprising, you see this? You can answer why my hand cannot touch the ball. Now here, I take this ball. This ball is not rising at all. You know why? Peacock. Mass, yes. Heavy mass. You know what is this ball? Lawn tennis. Lawn tennis, not table tennis. Lawn tennis. Okay, the heavy ball. Correct. Further. Okay. If I have this ball and I give a spin, okay. It keeps on spinning, but it doesn't fall. It comes down vertically. Okay. Now, you have noted one point that every ball will have a certain height attained. So height will be different. But if I take the two balls which are identical twins, same mass, same volume, same surface, same density, everything same, identical. Now what will happen? They will try to attain one position, but two balls cannot occupy one position. Then what will happen? Now they will keep on fighting. You know, like politicians. Okay? Oh. In the fight, they are fighting for one position and they are going around. Yeah, there is some very interesting demo. Now this ball. It is going to very high level but no stability. Now people ask why the ball is not remaining stable there. When it goes to very large height, it cannot remain stable there. But I will show you very interesting magic where I can have the ball is stationary. Have you noticed what I did? You know what I did? I controlled the RPM. Highest RPM is 16,000 RPM, 1,600 RPM. But I am controlling by some knob. Very interesting. So this is wonderful experiment where I can show you plenty of modification. But one of the best contribution is this. Suppose this is a filter. I keep the ball in the filter, it remains stationary. But if I keep it like this, it will not. It will fall. Simple logic. Why will it fall? Because the ball is on peak and it starts rolling down because the ball is spherical. It is not flat, it is spherical. Start rolling down, so it will go to low height. But the law of science says that every body will try to attain the lowest potential energy. What is the law? Every body will try to attain lowest potential energy. That means water will come down from mountain to the surface level, ground level, not go upwards. Yeah, water will go upward by evaporation, but liquid water will fall down. I am showing you magic here. You can see the ball. See the ball. See the ball. Have you seen the fun? Now imagine why this ball remains stationary here. Because it has got airflow coming through the holes and keeping the ball trapped. Okay, there are plenty of changes. But this ball is running. Surprisingly, small, medium size and big. The big will rise, the small will rise, and the medium will not rise. So, tricky. Come on. You find the answer. The answer lies in secret of this pipe. This pipe has got diameter and inner diameter, and this will block the airflow, and when it goes up, air escapes out, heavy weight, but this ball will block totally, and because of that it will lift up. Anyway, change the experiment. Come on. Bring it here. Here. Can you see? Yes? Can I? No. Light on it. Can you see? Everybody can see? Yes. 5 balls are there. Can you see the balls? Fine. I will not talk. I will only show the experiment. You can talk afterwards because there is a lot of time wasted in talking. I will show the event. Observe it carefully. Have you observed that when I leave one ball from this side and 2 balls from this side, after collision, one comes this way and 2 will come this way. But after that, again, 1 2 2 1, 1 2 2 1. You have to understand why this exchange keeps on happening. See this. Observe it very carefully and you record it properly. Yes. Very peculiar. But if I take one from this side and one from this side, then I observe that the middle 3 are almost stationary. The middle 3 are not moving at all. See, the middle 3 are not moving. If I take 2 2 from both sides, the middle will not moving because that will experience F1 and F2, which are equal and opposite. What is the rate for? 0. So no displacement because no unbalanced force acting on it. Newton's first law, inertia. Now, when I leave one from here, I get one out because momentum energy conservation. If I have 2, 3, 4, it is conservation. But something new you should learn here. And this is what is Newton's cradle beauty. You can learn a lot of physics in one simple apparatus. For example, here, if I remove the 3 balls and keep only 2 in picture and take 1 ball away and leave it. Normally people think when this will come and hit this ball, something will happen. What will happen? This will stop and will go ahead and will come back again hit and stop. See this? So, Funny. Very funny. See this? The ball which comes and hits will stop and it will go ahead. It is happening because they have equal mass. Equal mass. Because if one is heavy mass and one is light mass, then light mass ball will come and hit the heavy ball. In that case, this heavy will go some distance, but the light one will get back. It will rebound back. It will rebound. On the other hand, if it is light mass here and heavy mass here, heavy mass will come and hit the light mass ball. What will happen? The light ball will go far away. But what about heavy ball? Will it come and stop or continue moving or come back?
Stop.
Will it stop? No, answer is no. Continue moving to somewhere. That's the logic. Inertia. If light weight and heavy weight will come and hit light weight, then heavy weight will not stop but continue to move for some distance. This is because inertia, momentum, mass. Yes, I want you people to understand this simple logic that if you are thinking energy, momentum, conservation, then you should have clear idea about inertia. Now here what is happening? The masses are equal, so the moment it will come and hit, it will stop. And law of physics says hit and stop, not hit and run. No hit and run, it will hit and stop. Why it will stop? Because the two masses are equal. Because the two masses are equal. And if the two masses are equal, this happens. Now my question is, one will come and hit. कशाला कोरडे पडले मला इतका चांगला ऑडियन्स कधी मिळत नाही मला रिअली गुड दे आर सो मच कॉन्सन्ट्रेटिंग and never get such a good audience. Everybody is totally focused. I am getting tension now. Okay.
Clap for yourself.
Okay, now I want to tell you one interesting thing. If one will come and hit stop, but if I take both away and leave them simultaneously, what will happen? They will come and hit and stop. Yes or no?
Yes.
Yes? No. How many say no? Oh, you say no. How many say yes? Some people say yes, okay. So there is division, 50-50. Now, the two balls will come and hit, but they will not stop. I will tell you reason afterwards. But see the demo. Oh God. Keep on observing. They are banging non-stop and they are keeping on hitting for a long time. Now you have to tell me why. So, I'll tell you why. Because I want to save time. Okay? When they are hitting, they are exchanging momentum. If you argue P and minus P, 0. So both will have 0 momentum instantly. But this will exert force on this and this will exert force on this. So both are under force action. So they will be staying back. And they will keep on banging for a long time because they are very hard, very elastic, and the coefficient of restitution is very high. Coefficient of restitution is about 0.9798. So such a high coefficient of restitution means they will keep on, see, they are still banging. But have you noted one thing? That slowly distance is decreasing. It is called as exponential decay. Higher level you will learn the exponential decay. Plenty of things to enjoy with exponential. I have got some demo exponential decay also. But let us switch over to another event. Now, two are stationary. One will come and hit. What will happen? One will get out. Yes. When two are stationary, one will come and hit, one will get out. Will come back, they will get out. Now, if I take one from this side and two from this side, What is surprising, 1 to 2 or 1 to 2 are exchange. Yeah, why it happens, you think about it. But I tell you one simple thing, that the middle ball is changing the party. Once it goes to this party and then goes to this party, like politicians. Okay. Now, one is stationary and the two are banging. Oh, that is not moving. The middle one is not moving. Why? Equal opposite forces. You are learning basic law. Fine. Now here, suppose 3 are stationary and 1 will come in. 2 are stationary and 2 will come in. 1 is stationary, 3 will come in. Now 2 are stationary, 1 from both sides. 2, there are plenty of events. You can generate your own event and can explain logic behind it. That is the beauty of Newton's theorem. 350 years back, Newton made this type of toy first time, and he gave the idea of momentum energy conservation and inertia. But very few places you get this apparatus, and in many of the museums it is not working. I have seen all over India many science museums, but yeah, shall we? Okay, one event. One event you just. You know what is it? Multiple collisions. Multiple collisions. And in multiple collisions, one will come, one will get out. It's a very, very difficult to explain. When they are in multiple collisions, one will come, one will get out. Okay. It is high momentum and high energy conservation. Take it away. No? Yeah, bring the gyroscope. I have to go slightly on this side. Can you adjust the camera? I have to go here. You can see. Huh? Can you see what is this? A laser beam. Light is coming from water to air. It is changing medium. Light off. Can you control light? Yes. थोड़ा light कम करो.
Light कम.
Okay, no problem. It is. You can see.
Yes.
Now, I am asking question. Say, if I change the direction and make this angle say 10 degree, I get this angle as about 16 degree, 1/6. If I make this angle 20, I get about 28. If I make this angle 30, I get around 44. If I make this angle 40, I am getting around 60. Now my question is, why this angle is small and why this angle is large? It is called a refraction. What is refraction? When a ray of light goes from denser medium to rarer medium, it will bend away from normal. Have you heard this? Have you learned this? When a ray of light will change the medium from denser to rarer, it will go to away from normal. And now question is, if I increase this further and further and further, this goes to 90. But what will happen after 90? What will happen after 90, you know? Total internal reflection. See this, beautiful. The angle for which this becomes 90 is called as critical angle, and that is about 48 degrees for water air interface. Yes, here it is critical angle, and if I go beyond critical angle, beautiful phenomenon. What happens, you know? The ray will come from water, go back to water. It doesn't come in air at all, because 100% energy goes back to the same medium. That is why it is called as total. The word total is very important, and because of that total internal reflection, we are enjoying optical fibers. You know optical fiber? Have you heard about optical fiber? I have one demo on that also. It's very waste time. I have got 100 experiments. Okay, but yeah, you now people ask me the question, why it is called as total internal reflection? So lengthy name. Why you make physics difficult? I say it is not difficult, it is easy. Total means 100%, internal means no change of medium. Internal. And reflection means It is obeying laws of reflection. What is law? Incoming ray, outgoing ray, incident ray, reflected ray are on opposite sides of normal. Now angle of incidence is equal to angle of reflection. Angle of incidence I is equal to angle of reflection R. And if I make this angle 60, 70, 80, 85, 90, yeah, it will be raising angle. But have you observed that this angle and this angle is equal? Have you seen the symmetry? Very beautiful phenomenon. And we can always say that when the ray of light is going from water and going back to water because of total internal reflection, it obeys the laws. And second law is very important. The second law says that, first law is I equal to R, angle I by angle R. Second law says that the incoming ray, that is incident ray, normal and outgoing ray are in one plane. Now here my students ask me the question, what do you mean by normal? I tell them very simple. Normal is, remember 3 points, normal is an imaginary line, point number 1, drawn perpendicular to interface, point number 2, at the point of incidence. Have you got the third point? At the point of incidence. So you require imagination of normal, and this normal is here. Here is normal, okay? And this normal we are not able to draw because it is inside water. So it is, you have to imagine normal. Every student should be able to imagine normal, and then, all right. Now further, I go from air to water. That is wonderful exercise. Now, if I make the change air to water, I observe very interesting phenomenon here. When this angle is 10, I am getting around 6. When it is 20, I am getting around 12. If it is 30, I am getting around 19. If it is 40, I am getting around 26. If I is 50, I am getting around 34. If I make it 60, I get around 40. Surprising. When it is 60, I get 40. So remember, when I made 40 here, I was getting 60 here. It is because of law of reversibility of light. And I explain this in different ways, but one thing I like to take the reading out for angle of incidence, angle of refraction, you make column and give increment of 10, 10, 10 or 5, 5, 5 increment. And for every I, note down what is R. So you get a table, and the table you can make further 2 or 3 columns more. Angle I, angle R, sin R, and sin I upon sin R. So if you make this full table study, you will get a surprising result that the last column number quantity remains constant. And what is that quantity? It is called as refractive index of water. Very simple, no? And what is the law? It is called as Snell's law. So you can discover Snell's law experimentally, and that is the beauty of this apparatus. We can have several things. I will tell you one more thing. Not only Snell's law. You can see some light coming here. Now you may ask the question, from where the light comes? Why this light comes here? Why this light comes here? It is reflection. Partial, partial. Students are not aware of it. Partial reflection, because the ray coming from air goes back to air, but not total. It is partial because rarer medium, denser medium, and a total internal can happen only from denser to rare, and not other way. Are you able to understand? Please, are you able to understand what I say? Now, observe. What is the intensity of this spot here? See the intensity. Now, what is the intensity? See the intensity. Now, you see the intensity. What do you observe? When I go to more and more angle, I get more and more intensity, because intensity of reflected beam depends upon the angle of incidence. And normal here, normal is perpendicular line. So everything is possible. You can study. Not only this, you can change this medium, and in place of water, you can fill up kerosene, petrol, diesel, benzene, toluene, chloroform. You can put any transparent liquid, oil, and you can find the refractive index of that medium. Beautiful. So it has got some applications. Okay, we can measure refractive index using IR, Snell's law. And this apparatus is my own creation, idea, design, fabrication, carpentry, assembly at my own lab residence and my own workshop. Yeah, and I given a name. I given name also. The name of the apparatus is Tyroscope. TIRO. SCOP. Now what is TIR? Total internal reflection. O stands for observation, and scope means device. Physics people, science people, they should know microscope, telescope, oscilloscope, gyroscope, periscope, kaleidoscope, stethoscope, electroscope, magnetoscope. Have you heard these words? Plenty of scopes are there, but this is one addition, and this is my contribution to physics teaching aids. And this apparatus I had said in one competition, and I got Haribau Mote award on this apparatus. Okay, did you like the experiment? Change. Yeah. I am saving time. Changeover is ready. You know what is this? Found magnet, very powerful neodymium magnet. Neodymium. And if I make this magnet to fall through this pipe, you will find that it is not a free fall. It will have a slow fall. And time required from this point to this point maybe of 2 or 3 seconds. Now mentally you can count seconds, you know. How to count seconds? 1, 2, 3, 4. What is this? Second counting rate. You should learn it. Huh? Now, let's start. 1, 2, 3. Okay. Before I say 3, it is falling down. Check. Ready? 1, 2, 3. Within 20 say it falls. So very quickly falling down. But if you make it to fall from this side, it will fall within half second. Within half second it will have free fall. But this is not free fall. Now, I take a pipe of bit less diameter, slightly less, and make it fall through this pipe. 1, 2, 3, 4, 5, 6. 6 seconds. Check. I can repeat. 1, 2, 3, 4, 5, 6. 5 to 6. Okay. I repeat 3 times and take average. 1, 2, 3, 4, 5, 6. Okay, about 6 seconds. No problem. Now I take this pipe and I have counting start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So somewhere between 10 and 11 it falls. Check again. Repeat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 9 and 10. You know what? My counting rate may be slightly different. So what is the basic? Stopwatch. But stopwatch with 0.1 second less count or 0.01 second less count. And in Olympics it is now 0.001 second less count. 1 millisecond. That much accurate timing is taken in Olympics. You know why? Very sharp clocks are available now, very accurate. Anyway, have you noted the point that when the diameter is less, it will take longer time to fall down? The reason was given by Michael Faraday. Michael Faraday did pioneer experiment. What he did, he took a copper coil and made the magnet to pass through this coil. He observed that a current is generated and shown in galvanometer. It shows forward deflection, backward deflection, in out, in out motion of magnet in coil, it shows deflection left right. This is because the magnetic flux crossing this coil will induce EMF, and that is Faraday's law. And Lenz added one statement that this current will generate its own magnetic field, and that magnetic field will oppose the motion of this magnet. Very interesting. Fantastic experiments are there. I have done some contribution on this also in Faraday's law. I will show you that also. But here, remember one thing, that coil and magnet should have movement. Between the coil and magnet should be moving motion. But now question is, in small pipe why takes long time? Flux is same in big or small pipe, but in small pipe large time is required because distance from magnet to pipe is small, and at shorter distance strong magnetic field is there. So the magnetic field is strong near the magnet. Away from magnet, if you take a pipe of much bigger diameter, then what will happen? It will have free fall. It will fall suddenly within half second. Fine. So are you able to understand? Now, want to check it again? Can you count in mind seconds? Okay, start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, something is wrong with the magnet. Magnet disappeared. You know what happened? Magnet disappeared. Magnet. Where is magnet? Where is magnet? Nothing. You see the magnet? Is it there? Yes? Where is the magnet? Gone. Disappeared. Huh? Where is the magnet? Where? Magnet disappeared. They are smart. They are smart. Oh, you know what I did? I did one magic. I made the magnet to fall. Have you noticed? I was holding the pipe like this. And I was holding like this. So when I hold like this, my ring is closer to this pipe. And my ring has a powerful magnet here. And this magnet will attract this magnet in the pipe. It will block the magnet. Very simple. But magicians use magnetism in various ways. I am not a magician. I am physicist, so I will show you demo on Faraday's law. I want to take a photograph. Can I take your photo? Yes. My camera is there, and I want a flash. Yes, I have taken your photo. I have taken your photo. Very nice. Can you see the light?
Yes.
Can you see the flash? But this flash works without battery. There is no cell, no power supply, no energy source. It works without battery. Now people ask, how can you make a flash without battery? Faraday's law. What is Faraday's law? This coil is there, and inside the coil you push the magnet up and down. You get current. But the funniest part is that I am having a cylinder, and inside the coil I am having a magnet, and that magnet is floating in air. So people ask, how can you keep magnet inside the coil floating in air? Answer is very simple. One magnet is here, and one magnet is here, and third magnet is here. And how these magnets are planted? They are repelling. You know what repelling? It is north, south, south. Deviation. Now people ask, you are saying something, can you prove it? I can prove it. Can you imagine? Powerful magnet is there. Yes, can you see? my coin, you know what is this coin? Nickel alloy. And this is getting stuck up in center also, because in center it is magnet. Okay. Now, further magic, very basic. I am making this movement and now my flash is not working. My flash is not working. Something went wrong. Connection broke up. But now it is working. Now it is working. Yes, what do you want to say?
Sir, you need a very high vibration
Oh.
for it.
Oh, you require high speed. You require high speed switching on off. You know why it is? It is because of E is equal to minus d phi by dt. Rate of change of flux with respect to time. Rate of change of magnetic flux with respect to time. D phi by dt is 2 becomes without no derivative. But I will tell you simple logic. Logic is that if the magnet is moving up and down with high speed, then only some current will be generated. If it is going slow motion, this flag doesn't work. Now I tell you why. Real. If I make speed slightly faster motion, can you see the 3 LEDs and 3 LEDs? You know why? 3 LEDs in this direction, 3 LEDs in this direction. They are forward, backward. Anode, cathode, cathode, anode. You know? Back to back connected. Fine. They are anti-parallel. 3, 3. Parallel and anti-parallel. Fine. One more thing. Very basic thing. If I make slow motion, sometimes I get little bit flash, but not continuous. But if I make high speed, I can generate AC, alternating current. And this AC I can turn into DC. And that DC I can use for my mobile battery charging. I can charge my mobile battery using this charge current. Further interesting thing, which is difficult for you people to imagine also, but I try to make you understand this easily. When I make slow motion, the magnet is moving inside the coil, but small motion is there. But if I make high speed, it moves faster. But one point, learn properly. When I make slow motion, magnet 1, magnet 2, magnet 3 and coil, they are all going with the same velocity up and down. Now because if it is the same velocity, what happens? The thing which happens is that there is no relative motion between magnet and coil. I repeat, between magnet and coil, some motion should be there. Either magnet fixed or coil fixed. Both are moving with the same speed, no use. Secondly, now higher level physics. When I make this motion, the magnet inside the coil is moving with the apparatus. But if I make it fast, it jumps up and down. The reason is the magnet inside the coil has inertia. Now what is inertia? It will try to maintain the position. But if I make this coil to fall faster than gravity, and the magnet is there, coil is going up and down. Oh, very interesting thing. Magnet is there, floating there, but the coil is going up and down. And these are magnets pushing up and down. So it will make frequency vibrations. And these frequency vibrations are making sine wave. And that can be seen on oscilloscope. I can see sine wave. Beautiful study. Anyway, there is endless studies are there. I think people like to see the magic. You know magic? You know what is this? It is a bowl. Empty bowl. Plastic utensil, container. And in that plastic, I have put coin. 1, 2, 3, 4. I put the 4 coins. Now, I make a magic. 1, 2, 3. Come on. The coin disappears. The coins disappear. Where are the coins? Coins are gone.
Sir, your ring has a magnet.
No, my ring is here. My magnet is here. Empty bowl, plastic bowl is there. But magnet, where is magnet?
Sir, there's a trap inside.
Yeah. Oh God.
Sir, the 4 coins.
4 coins are there, but how they get stuck up to plastic? Surprisingly.
There's a magnet behind it.
Where? No magnet.
Inside.
Okay, I hold it like this. Come on.
Sir, I think there's a double cup.
Very good. So you are having proper line of thinking. Very good. Clap for him. Clap for him. It is a double cup, and between the two utensils, I have concealed a plate. You know that plate? It is neodymium magnet flat. Flat. Very thin. You know how much thin? Like razor blade. You know razor blade, shaving blade.
Yes, sir.
Very difficult to make such thing, but you have to go to market, search for this and bring it, assemble it. But making this is a joy. Anyway, yeah, change over. Yeah. You know what is this? Pendulum. Pendulum, but not ordinary pendulum. It is a magnetic pendulum. You know magnetic pendulum? I got a magnet. What magnet? Very powerful neodymium magnet. Magic magnet. Magical. And this is going free oscillation like pendulum. And now this is metal. Slab. What metal it is?
So nickel.
Aluminium. You can see the shining. Nickel is different. Aluminium and very thick, very heavy. Aluminium is not heavy, but it is because of thickness. Now, if I ask a question like, why this magnet doesn't get stuck up with aluminium? Because aluminium is paramagnetic. It can get stuck up with ferromagnetic, and ferromagnetic I can have another magnet which is ring magnet, but this will not get stuck up. Why? It is paramagnetic, very weak as well as negligible attraction. But if I make a free oscillation and if I keep this slab very properly positioned and suppose the length is adjusted in such a way that the magnet is not touching the slab. Magnet is not touching the slab, it is above by 1 or 2 millimeter. And 1 or 2 millimeter. And I make this free oscillations. Oh, great, surprising. Right? You know what happens? You observe carefully. Observe carefully. What happens? Sudden stop. Oscillations are getting damped. Now you have to think why. Why it is getting damped? Because this magnet, when it is trying to oscillate over this plate, it generates current in this slab, and that current is eddy current. Those eddy current loops are generated, and those eddy currents are so powerful that they generate their magnetic field, and that magnetic field will always oppose this magnet. Are you able to understand? But instead of this, if I take a plastic slab, it will not work. It requires metal. And if I take copper, silver, gold, nickel, something, nickel is ferromagnetic. It will have very strong. Cobalt, iron, and nickel, they are ferromagnetic. Others are para and dia. Copper is diamagnetic. I got copper slab also, but you can understand that the oscillations are damped easily, heavily because of this, and we call it as magnetic break. It is called as magnetic break. Be smart. You pick up very fast. And once you pick up, you should remember lifetime. Never forget it. Magnetic break. Okay. What is the advantage of magnetic break? No contact, no friction, no wear and tear, no maintenance. Only you generate a current, magnet, and you have a break. Very damn interesting. And it is having real application of science to practical field. There are plenty of things. Okay. Now next stage. Come on. Yeah. One more magic is coming. hammer. This hammer is very powerful. Yeah, this hammer is very strong hammer. Huh? No misuse of it. Yeah. I am having a thread tied to this hammer and some hook. Okay, some hook is there, and I place this hook in a wooden plank. You know what is the wooden plank?
Yes, sir.
Simple, and it has got some hook, and I keep this on your side. I am keeping this here, and the hammer is remaining equilibrium, stationary. Now people ask the question, this heavy part should fall down, will go down, but this is getting balance, equilibrium. Okay, you have to think. But for that you require understanding of center of mass. Center of mass is one basic in science, very basic. Now, I will ask you a question here. This is remaining stationary because the center of mass of this hammer and wooden plank is in the plumb line below the support. Okay. Now, if I bring it on this side, you know what I'm pushing on this side. I will push on this side, and still it is balanced. Again I push on this side. Still it is balanced. Again I push on this side. So now I am coming to the A. Still it is balanced. Now I am coming to the A. Surprising. Again, further balance, and I give a small pressure. Good. So my hammer and wooden plank, they are oscillating like pendulum. They are oscillating like pendulum, but they are not falling. Now the question, why they are not falling? The answer is very simple science. They are not falling because the center of mass of this assembly is in the plumb line of this edge. You know, edge, like upper wooden plank edge. So it is like a seesaw, balancing. Now, this is center of mass idea. Now further, I have done modification on it, and that is something you will like. If you ask me that you are adding the hammer, but please tell me where is center of mass of this hammer. Where is center of mass? Now, generally people never get real idea of center of mass, but by this experiment, they will never forget this. Once experiment is, you will remember lifetime what is center of mass. You know, how to find center of mass? I have found a very simple trick. Take one hook and hang this hammer by thread. You know, one plumb line is coming. So center of mass is somewhere on the plumb line. But on plumb line there are millions of points. So where is center of mass? I will tell you where is center of mass. Take one very strong magnet and take one plumb line and use this magnet to suspend this hammer. Oh God, very, very powerful magnet, and this heavy hammer is held, and from this point drop a plumb line perpendicular. Can you imagine where is the plumb line going? Yeah, through this point. Now this is second. Now you take third point and again drop the plumb line. And these three plumb lines will pass through one point. Yes, what is that point called as? Center of mass. You got the idea? How to find center of mass? Use 1, 2, 3 or any number of plumb lines. But you take any point and suspend, the plumb line will pass through center of mass. That is difficult to understand. And best thing is make an obtuse angle triangle, cut the model and find from the vertices plumb line. Beautiful experiment. It was Olympiad, school level Olympiad. I have not got it today, but it is really a joy to learn that experiment. But remember that the center of mass of this hammer is somewhere here. Oh, very good. Can you see where is center of mass? Where is center of mass? Screwdriver piercing the hole, center of rod, there is center of mass. But higher level intellectual development, see this, where even college students don't understand what I say. When I take this like this, it should remain stationary, but no, it's not remaining stationary, it comes back. If I keep this like this, it should remain stationary, but no, it is coming back. Anyway, I leave this way or that way, it comes back and it remains like this only. And I always observe that my iron is on my left hand side and wood is on my right hand side. Can I make it other way around? Wood on this side and iron on this side, yes or no? No, I can make it, yes, why not? I have got a very simple trick. I do a slide. Come on. Now, yes, iron is on this side and wood is on this side. Change. Difficult to imagine. People keep on wondering what is this going on. It was wood on this side and iron on this side, and now I leave from this position or this position, any position. It comes back to equilibrium in same condition. To answer this question is very difficult. Very difficult. Normal science one also cannot do it. But I make you super than normal. I give you the secret behind it. The secret is that actual center of mass is 1 millimeter below this screwdriver line. Slightly below. Slightly below. 1 or 2 millimeters down. So, the plumb line passing through this is passing through center of mass. And if the center of mass is above, it is not stable. It is come, it is stable. Okay, friction. It is friction, yes. You got it? Are you getting my point? Where is center of mass? Slightly below screwdriver line. If it is exactly in screwdriver line, then it can remain stationary like this, or any position it can remain stationary. But the beauty of center of mass is that you can give the rotation very freely. Okay? But if I make another hole and make another screwdriver and then ask the question that where is center of mass? Yes. It is below in plumb line. Now if I keep the hammer like this, will it remain like this or no? Will it remain like this or will it fall? It will fall. Why? Because center of mass is supposed to come down towards gravity. Toward
the earth. So what happens, our mother earth will pull the whole body, but the entire force will be passing through center of mass, and the earth will try to make center of mass as low as possible. Great science. Center of mass will be in the lowest possible position. I hope you are able to understand everything. So you are coming to college level now, because the center of mass and these experiments are very interesting in many aspects. Fine. Bring it. For school level people, typically I am giving this experiment. You know what is this? Magic. What magic? The ball is floating in air. Now tell me why it is floating in air? Yes. What can be the reason? Magnet, very magnet. This is aluminum and it is plastic. Very magnet.
So there is the tension of the string. It's tension.
Tension in the string. Like this. It will remain like this floating here. No, fall down. It will fall, gravity. But here it is remaining floating. So very simple. You should learn common sense. That there should be some force of attraction between this and this. And that force of attraction is there. because magnets are there inside. Inside this and inside this magnets are there. Inside the ball, neodymium magnet, like that one I use for pipe, and inside this also very strong magnet. But my question is very tricky now, very tricky question. You have to answer with proper sense. Huh? Where is magnet? Suppose I got a magnet here and I got iron here. It will work. A magnet and iron will work. Why not? Why not? Magnet and iron will have attraction. Or I got a magnet here and I got iron inside. It will work. But can I have magnet here and here both? Can both be magnets? Yes or no? Yes. Under condition. What condition? They should attract. That means unlike poles are facing. Yeah, this is development of common sense. I should have north pole here, south pole here, or vice versa. Suppose I got north pole here. Then what should be pole here? South pole. Then only attraction will be there. Now the question is, can we prove that there is a magnet? There is a magnet inside. I can prove it. See how? Yes. I can prove magnet is there. I can prove magnet is there. But suppose you don't have coin available, and without coin you have to prove both are magnets. How will you prove? By repulsion. Okay, good. That is the idea. If there is north pole here, I should have south pole here, and I should have north pole here. Yes. And if I bring north pole near north pole, oh beauty. See what is happening there. What is happening there? Yes? Repulsion. Why it is repelling now? Because like poles repel. This is the way of learning science. Simple, but very effective. Remember, hundreds of experiments I can show you on magnetism. Here, only one thing is that some students are slightly higher level, some from college and some from junior college. For them, I have one addition in the experiment, and this is what you should learn at higher level. So I will show you that also. In the gap between ball and stand, I pass a cardboard paper. People say if you pass the cardboard, it will fall down. Why it will fall? Because you are cutting the lines. But surprisingly, it doesn't fall. Now I take thick cardboard. You know what is this? It is a cheese box wrapper and nothing. I take a thick bakelite sheet, very thick, very heavy, sturdy material, and I pass it. Nothing. Then I take a thin aluminum foil, very thin aluminum foil, Girnar tea, advertisement. No? Okay? Yeah. Now I take thick, multiple layers and pass. Nothing happens. Okay? Then I take CD and pass. Again, transparent. So I learned that all these media materials are, now what is this? Aluminum, thick and pass. Transparent, paramagnetic. Now, I take glass plate. Now people say if you put the glass plate, it will cut the lines and it will fall. Yes or no? Yes or no? No. Okay. Yeah, it doesn't fall. Fine. But now I change the medium. I take mirror. Now what happens? Mirror will reflect the magnetic field. So if I put the mirror, what will happen? It will fall. Common sense. No, people are becoming smart. They know I am making some tricky equation, so they say no. Okay, I'll show ferro also. Huh? I got ferro, I'll show you ferro also. See this. Look, here you go. It doesn't fall. It is not falling. So I learned that all these media are transparent. for the lines of force, magnetic lines. Now, best. You know what is this? Iron. And what is this? Magnet. So it is ferro. Now I put ferro in the path. What will happen? The ball will fall. Yes or no? Yes or no? No. Ball will fall or not fall? I put iron. It will fall. Why it will fall? It will cut the lines. It will block the lines. Okay? But my magic continued. I put iron. And it is not falling. Is it not magic? It is magic. I put the ferro and the ball is not falling. Gap. Okay.
You should suspend the iron sheet freely. Because when you touch the iron sheet to the magnet, it again becomes a sort of magnet. So try and suspend it freely.
Are you sure?
Yes, sir.
Okay, now I'll tell you the science behind it. You're right. Clap for him. He is right. I'll tell you what happens here. See, learn science with joy, you know. Learning with joy. You should enjoy learning science with experiments, huh? Not theory, practical. No. The moment I bring this iron sheet near a magnet, this becomes a magnet. It is called as magnetic induction, or it is called as induced magnetism. Induced magnetism or magnetic induction, चुंबकीय प्रवर्तन, क्या प्रवर्तित चुंबकत्व. I am getting this magnet, but how? How this becomes magnet? If I got a south pole here, I get north pole here, and again I get south pole here. See this? So south, north, and south, and this south pole will always attract this north pole. As simple as that. So we learn here that induction is making this phenomenon. Don't say that this is transparent for magnetic field. Don't say it is transparent. Say it is induction. Why? Are you getting the sense clear? This is very important. You do some experiments, but you should get logic behind it. What is logic? Induction, magnetic, induced magnetism. Fine, change.
Can it fall with some material? Can it fall with some material?
Suspended.
Yeah. I will give you the answer. This answer is at MSc level. They may not understand, but I will give the answer. If the ball is suspended and I put a superconductor medium in the path, it will fall. Second thing, recently scientists have developed a medium called a mu metal, and that mu metal is able to block the lines, and that is called a shielding effect. They do the shielding, magnetic lines cut. Yes, mu metal. You can go to the Google and put mu metal and magnetic shielding to get the knowledge. Lot of knowledge available in Google. You can search, and here this ball will fall. But once a student asked me the question that you are having so many material mediums, and every medium is having transparency. But if you take all mediums simultaneously, what happen? Will it fall or not fall? It will fall or not fall? Not fall. Nobody is answering, huh? It will fall. Iron is not there. I am having all transparent media.
But basically, the lines of force pass through the air.
Yeah.
If you have north, south, and south, north, then it works. Because the iron shields the, like basically blocks the
Yeah.
lines of
There is,
north and south, like the
right. There is interesting medium about it. Okay. See this.
So you should block the lines of force.
Oh, what I done, you know? I put all mediums together, but still not falling. Tell me why? All are transparent. Yeah, all are transparent, yes. For magnetic lines of force, for magnetic field, all are transparent. So no cutting, no shading, nothing. But if I put iron in the path, it may fall or it may be pulled up. So let us try. Now I put iron, and now I try. Very difficult. Oh, surprisingly, it doesn't fall. My iron is transparent. No, no, it failed because of my touching. Okay. Anyway, think about it afterwards. I give you homework to think about it. Change. Take it out. Put the rod here. I am making bell. Some students are sleeping. So by this bell they get wake up. Anybody sleeping there? No. Okay. You know what is this? Hammer. Very typical sound comes. I am getting beautiful, very nice sound. But if I use my pen, I am getting sound. And if I use hammer, now question is, this frequency and this frequency, are they same or different? Yes, 99% people say different, but it is wrong answer. Common sense is nonsense sometimes. Sometimes common sense is nonsense because science is beyond common sense. This frequency and this frequency are same. No difference. Now people challenge how you prove it. Very simple. I take condenser mic, I pick up the signal, amplify and give it to oscilloscope. Now this is, same. Exactly the waveform, and he's showing me the waveform. On the oscilloscope I done it. I done it on oscilloscope. Yes, that is oscilloscope, correct. But I can, you can store it. You can store it, fine. I'll tell you science behind it, science. When I hammer it, this vibrates vigorously, large. So amplitude is large. And if the amplitude is large, intensity is large. Because the intensity is proportional to square of the amplitude. And if the intensity is large, loudness is large. We get loud feeling, okay? So amplitude, intensity, loudness, these words are indicating the strength of the sound wave, okay? But this frequency and this frequency are the same, only amplitude is different. And people ask the question, why the two frequencies are same? The answer is, when I hammer the bell will vibrate with its own natural frequency. Natural frequency depending upon what factors? Size, shape, metal, then elastic property of metal, and so many things. So frequency of each bell is different. If metal is different, size is different, shape is different. In your home also you have some bell, it has some sound. Anyway, my question is, to make the sound wave, is it essential to hammer the bell? No, not at all. I can make the bell sound without hammering. Without hammering. I will use one technique which is used by Buddhist people. Are you waiting? Now question is, why the bell makes sound? Yeah, because of friction. There is a friction between this and this surface. And have you heard of carefully that I was able to modulate the signal, and I was able to generate waxing and waning. Have you heard these words? Waxing and waning? Intensity large and less? Yes. But one difficult question. Yeah, what do you want, sir? Okay. One interesting.
Like audience to see that the wave is.
That will be captured on the app and
Oh, you are showing actual online. Fine. Very large intensity there. Anyway. Yes, sir, you should have told me before. I would have done better than this. Okay. Okay. I will ask you a question. I am making this sound. It is very easy. But now if I put this rod in water and I have made it weight by water. I am not able to generate sound. You know why? Because the water will work like lubricant. It will make less friction. And no friction means no sound. Very simple logic. Fine. Okay, change over. I like to come this way. Give me the prism. Yeah. Can you have the camera here? Please. Try to focus on this. Okay, see this. Can you see the line? What is this? Laser. And you can see on this side. I will show you this way. Okay. Now, this line, this ray goes in straight line, but on the path I insert a prism. It is push fit. Okay. Very nice arrangement. And if I make the ray to pass through prism, surprisingly, the ray is coming like this and bending downwards. Can you see this? Can you see this? Can you see this? Okay. So we have a very interesting experiment where ray will come, enter the glass, bend, again leave the glass, bend and go down. Now why this is bending downwards? It is deviation. What is deviation? Angle between this line and this line. Now, here this happens because the ray is changing medium twice. Once it goes from air to glass and then it goes from glass to air. Air to glass and glass to air, twice change. And this twice change of medium will make double bending. And these two bendings are added up to get large angle of deviation. And this prism is of a typical glass, has some refractive index. And you can observe one phenomenon here, and that is beautiful phenomenon, angle of minimum deviation. Medium deviation is difficult to understand in all levels, but I have made it easier by giving the rotation to this prism. You can see the prism can be rotated either clockwise or anti-clockwise. I can turn clockwise and anti-clockwise. So by turning this prism like this and like this, how the reflected ray comes out. See this. It is going down. It is coming up and going down. Again it is coming up and going down. So it again you check, comes up and go down, comes up and go down. I turn anti-clockwise, I turn clockwise, clockwise, anti-clockwise. Every time I find this comes up and go down. Now people ask the question why it comes up and goes down. It is angle of deviation is changing in a U-shaped graph, and this U-shaped graph has a lower minima, and that is called as angle of minimum deviation. Okay, so this is very interesting. But point to be noted here: instead of green laser, if I use red or blue, I got blue also, I got red also. But let us imagine if I instead of green, if I use blue or red, I will get this angle different. Because for every color frequency, angle of deviation is minimum deviation different. Second thing, if I put a powerful white light torch, you know what I'll get? I'll get spectrum, dispersion, color separation, and these colors will come VIB, GYOR, white light. Okay, I can get 7 color separation like Newton's concept. Fine. Anyway, this is again a very special instrument. I have given it name also, and that name is vertical spectrometer. You know why vertical spectrometer? In lab, spectrometer is horizontal. Now, why it is horizontal? See this logic. Why it is horizontal? Because there is one source of light, there is one collimator, there is one prism table, and there is one telescope, and one eye can observe at a time. But here, 400 eyes can observe at a time because it is laser. What is the specialty of laser? No collimator required, no telescope required. On the contrary, you should not see the laser by naked eye. You know why? You will become blind. Laser is very dangerous. So, you should handle with care. Remember that this powerful light which comes on the screen here is so strong that by mistake, if you put it in somebody's eye, he will become blind by that eye. Very, very risky. But I have the special collection of lasers, and here I am showing you something interesting. Can you see? Lock it. Hold it. You can see this. What is this spot? Come here. Okay. Yeah, see this? Can you see the line here? This line is coming because in front of laser beam, I put a glass rod, small diameter glass rod. So the moment I put the glass rod, I get a line. You can see the line there. And remember, if the glass rod is horizontal, line becomes vertical. And if the glass rod is vertical, line becomes horizontal. Very interesting thing, you know. Now people enjoy learning the spectrum, and for spectrum, you can put a bright light source here. First you give me that one, correct. School level people never get chance to see the spectrum, but I am showing you the spectrum. You can see what is this? Yeah, what is this? 1, 2, fine. What is this? LED. LED means what? Light emitting diode. Now in front of LED, I am putting a thin film, very special film. and see through this thin film. Can you see what is this coming? Can you see what is coming? Yes? You are getting spectrum on both sides. That is first order. And if you observe carefully, second order is there, but intensity is less. So we can get spectrum, spectrum separation of wavelengths by this thin film. And this thin film is called as diffraction grating, linear grating. Linear grating is at college level, but to see the spectrum is a joy. So we can always enjoy. And if I take a tungsten filament bulb, I'll get continuum spectrum, all frequency wavelengths. But if I use element source, I'll get beautiful line spectrum. Now the beautiful line spectrum comes because elements can give a line spectrum only. Yeah, I'll show you line spectrum. Yeah, you know what is this? Tube light. Mercury vapor lamp. Yes, it is mercury tube light. And in front of mercury tube light, I am putting a thin film. Can you see that? Yeah. Can you see? On this side? On this side? What do you see? Oh, you have to make perpendicular. Huh? Can you see? Bring it near. Take it away. On the front. On this side. Observe it very carefully. Observe it very carefully. Tell me how many colors you are able to see? Many, many colors. Can you describe which colors are there? Yeah, red, green, blue, violet, and that is mercury spectrum. Mercury spectrum is beautiful, and in lab we use instrument called a spectrometer, like this spectrometer, to separate the colors, and we get prism spectrum. But this thin film is not easily available, very special, and bit costly also. This film is nominal 300 rupees. Okay, so that is very made in America. It is actually imported one, but you have to enjoy learning spectrums. Best thing you can do is solar spectrum. Through this, you observe solar spectrum. You will say, "Ah, this beautiful spectrum." Solar spectrum is continuum with dark lines, and they are called as Fraunhofer lines. Fraunhofer lines, college level. We have to study absorption spectrum. Okay. Anyway, there are so many things, but I want to ask you one question, that this is laser, okay? And if I make this laser to pass through this film, you can see what happens there. Can you see this? Can you see this? Okay. If I put one beam, I am getting right, left, first order, and if proper adjustment done, second order also is there. Intensity is less. Okay. So this is diffraction grating. But now I will try to explain you one simple fact. What is this laser? Red. And if I use on the screen there, here, vertical. Try to remember what is the distance between the main spot and the first order. What is the distance? You try to remember. And now you hold this. And now I am taking red. See the distance between main spot and the first order. What do you observe? The distance here is large. and with the green it is small. You can put the green, I will put the red. Now, this is main spot. Can you see the difference? Make the spot coinciding. Can you see the difference? Make it vertical, proper. Okay. थोड़ा इकड़े ना ऑन कर. Yeah, have you seen the difference? Main spot is coinciding, but red is above and green below. Now my question is, why this separation of direction comes? Why red is above and why green below? The answer is frequency or wavelength. The red has more wavelength, green has less wavelength. So one which has more wavelength will have more angle, because the formula is d sin theta is equal to n lambda. Here n is equal to 1, lambda is wavelength. So I understand very simple sense. Large lambda, large sin theta, large theta. Large lambda, large sin theta, large theta. And small lambda, small sin theta, small theta. Theta is the angle. Okay. So very simple way to learn complicated phenomena also, and that is beauty of this spectrum. Now those who are not able to understand my idea how to generate a line, I will show you them demo. What is this spot? It is red spot. Now what is this spot? It is green spot. Okay. Now what is this? You know what is this? Glass rod. I am making the laser beam to pass through glass rod. I am getting line. Can you see the line coming there? Now how this line comes? Because when a ray will pass through this glass rod, it will work like spherical lens, and this lens will have spreading of beam, and it is monochromatic source, single wavelength, but we get very nice line. Anyway, many people ask the question that nowadays we are getting no tube lights, but we are getting LED sources, and these LED sources are very easily available, and you can see this beautiful tube light, but it is not tube light, it is LED source, and we can hold a grating in front of it to show beautiful spectrum. Are you able to see the spectrum? On this side, on this side, on this side, okay? But the betterment can be done. Instead of taking broad, make a slit. You know how to make slit? Two blocking surface with line opening, and we can make beautiful spectrum, but this will not give you line spectrum because it is LED, it will give continuum. Okay. RGB, red, green, blue, three, like this it will give RGB, red, green, blue. Okay. Sir, how much time is there? I want, yes?
Actually, our time is already up.
Oh,
It's already time.
I am enjoying it, but
10 minutes.
more. I have overcrossed. Okay. I jumped over the limit. Okay. You want, are they interested in more experiments? Are you not getting tired? No, you are not getting tired? Okay. I will show you some other. It's a very happy. I thought they will get tired after 2 hours. अरे गे पटापट पेन दे take it तो लेजर के okay 1 minute start Yes, can you see this? All of you? Light off, light off. Now I always ask the students, are you interested in observing the magic? You like magic? How many like magic? Raise your hands. Okay, I'll show you magic. Fine. Now see the magic. What is this? A chain of LEDs. Now, if you want to enjoy the magic, you should obey my orders. Okay? You should obey my orders. When I say close your eyes, you should close your eyes. When I say open your eyes, you open your eyes. Now, come on. Start. Close your eyes. Open your eyes. Oh, great. Real magic. See this magic? Huh?
Can you please repeat it?
Okay, you want to see one more magic, huh? See this. Now, yeah, what is this, Infinite number of images inside. Now, close your eyes and open your eyes. What do you observe? Yeah? What do you observe? Double chain. Previously, one chain was there. Have you noted one chain? Now double chain. Now again, close your eyes and open your eyes. What do you observe? What do you observe? Have you noticed the color change? What is the previous color? And now what? No, blue. And now what is the color? Golden yellow. Okay, there are beautiful colors available, and I can show you one more beautiful color, and that is tell me what color it is. It is pink. No. What is this color? Violet. Okay. Purple. Okay. Now I am changing the color. Green. Beautiful. So this is the real magic. I just change the glass. I get change of color. I change the glass by rotating 180 degree. I get change of color. And many people never understand what is this happening, what is going on here. This is very high quality special glass. In market they say one-way glass. One-way glass because if you are in the glass house and inside there is dark, outside lights are there, you can see from inside to outside, but outsider cannot see you what is inside. On the other hand, if inside light is there and outside dark, then outside people can observe what is in the glass house, but glass house person cannot see what is outside. So it is like one-way glass, okay? So it is, you know what is this called as? It is called as partial mirror. Partial mirror with one face given a very small plating, doping. Now this plating on the surface, very small plating on the surface makes color, and that color is golden yellow or blue. Actually, very difficult to understand this construction, but I'll tell you simple language. The glass is bluish tint, and on one face only color is plated. On one face only color is plated. Okay, color plating is there, thin layer meeting, and that is very simple. But if you take one more mirror and put that mirror in company with this mirror, you will see the beautiful change. Can you see? Can you see on this side? On this side? You know what is this? Multiple images. Very spatial. You have to see through this gap. See through the gap, you will get multiple images inside. And that is because of two mirrors. But one point to be noted, this is called a total mirror and is called a partial mirror. And if the two mirrors are partial, no, one is total, one is partial, you get infinite number of images inside. Okay. How much more time can I take? Or you tell me, I'll stop. Yes?
Some other engagements also.
Okay.
So that's why.
So they have to. Okay. Thank you very much.
We can come again.
Yeah, we'll definitely have one more session with sir, maybe later.
Okay.
Experiments, or when nobody is feeling more and they want to continue, but no, we have, but that's not the end. That lecture, you'll find how many trees you need in 1 acre, how many trees you can plant, how many people are there on the earth, how much oxygen, how much. Just try to do those calculations, and that's what just a small attempt from our side, just to encourage. Let us plant more and more. So thank you very much for the entire team, sir. I think they can all come, and I'll request. Avni is there. Avni.
Sir, I got hundreds of experiments.
Yeah, for the entire team on the stage, sir. And then we'll have a photograph for all of you. Because parenting, but to make it smooth, you can see there are 4 people on the behind the scene. Just like when you watch a movie, and if you see at the last, when numbering comes or the acknowledgement, there are hundreds of people in that. So each one of them, they deserve a thanks and a round of applause from all of us. Sir, आप एक बार यहाँ आ जाइए please. Sir, 1 minute please. Let's have a photograph with sir. और आप लोग तालियां